Hi, my name is Zang, and I'm a research specialist at the Hawaiian Islands Humpback Whale National Marine Sanctuary. We're out here today in the West Maui waters right off Olowalu to recover one of our acoustic mooring packages. This is part of many efforts that we have at the sanctuary, different research efforts. For example, we do short-term tagging that helps us understand what the whales are doing beneath the surface. It helps us to quantify their activity levels and also gives us an idea of what they're doing overnight, which little is known about humpback whales and what they're doing overnight. We also do vessel surveys to help quantify and estimate whale densities in our waters. And then the other part of our research involves this acoustic monitoring. And acoustic monitoring is really valuable. During the months December to April, whale chorusing is the dominant sound here in our Hawaiian waters. And so by monitoring that, we're able to get an idea of what's happening with them. So when they're arriving to our waters, their relative presence in an area, their peak abundance, and then also when they depart. So these acoustic monitoring packages that are bottom moored, they can stay out for months at a time. And so we deploy them before the season and recover them after the season, and then see what we get back from the data. So today we're going to be recovering one of our deep water ones, and our deep water ones are deeper than 100 feet, so we can't go and get them on scuba. We have to put them on acoustic releases. And the one you'll see today, it actually has a device where it will leave the temporary anchor and it'll just unscrew and the whole package will come to the surface. So it's got a float, the instrument, and then that acoustic release, and that's what sits vertical in the water column. And so each acoustic release has a unique code that enables us to talk to it. So that's what I'm going to do right now with this instrument. I'm going to put this in the water, the transducer, and that'll send that unique code to the instrument, wake it up, then I'll tell it to release, and then we'll go ahead and look for it and retrieve our instrument. Line going over. So this first code just basically wakes it up. So that helps preserve battery life since it's deployed for several months at a time. So you can hear that little ping, that's the signal being sent to the instrument. So we're 111 meters away from it, which is perfect. On a calm day like this, we'll be able to see the big bright orange float that we're going to be looking for. So I'm going to go ahead, I feel comfortable with that distance, and I'm going to go ahead and send the release code. So now the package should be at the surface in about 3 to 5 minutes. So we're going to do a full boat watch and see where this instrument pops up.
There it is, just popped up, just off our bow. Neutral.
All right, so we have recovered the acoustic recording package. As you can see, there is a lot of what we call biofouling on this. So organisms have found this in the ocean and decided to settle upon it. We've got some barnacles, some pen shells, lots of hitchhikers and crabs, so we'll try to get those overboard as quick as possible. This is the sound trap, and this is what we call a hydrophone. So that's the underwater microphone that actually captures all the sound. And what's housed inside of this metal canister here is basically the computer. That's how we program it, when we tell it to record, at what frequency range we'd like it to record. And so what we'll do is when I get back to the office, we'll be opening this up and removing the hard drives and downloading all the data. So fingers crossed, we got some good data from this whale season, and we'll keep you posted on results.